Well, welcome everyone. This is Geometry Chapter 11, Section 2, Surface Area of Cones, Cylinders, and Spheres. Last section, we talked about the surface area of right prisms as well as pyramids. They were adding 3 more shapes in. These shapes are not going to be polyhedron because they're all curved. So let's just start off with a formula. The surface area of a cone. Surface area, or as we've been calling it, SA, is pi r squared plus pi r L. Once again, that L is going to be our slant height, and like before, R is the radius of the base. So you might recognize pi r squared. Pi r squared is the area of the circle on the bottom there. And then the pi r times the slant height, L, is going to give us the surface area of the rest of the cone. So on example 1 here, we're supposed to find the slant height of this right cone, meaning the cone has a right angle here, okay? And then we're going to find the surface area of this cone. So the slant height, we see a triangle here, 24, 10, and our slant height L, and it's a right triangle, meaning we can use the Pythagorean Theorem. So we set up 10 squared plus 24 squared in either order is equal to a slant height squared. That gives us 100 plus 576 is our slant height squared. 676 is equal to L squared. Square root both sides, and our slant height is 26 centimeters. So that's one of our answers. Now we have to use that to find the surface area. So let's go ahead and plug everything into our formula since we know all of it. Surface area is equal to pi r squared. Remember, r is 10 right here as a radius. The circle, point on the circle to anywhere to the center. So pi times 10 squared plus pi times 10 times 26. And you can type this all in your calculator if you want. Or if we want exact answers, which sometimes we do want answers in terms of pi or not rounded, we take 10 squared and get 100 pi, and we take 26 times 10 and get 260 pi. And we'd add those up and we get 360 pi square centimeters. Looks like I miswrote earlier. I just noticed now that I miswrote earlier on my slant height. I wrote in that it was meters, but it's centimeters. And then my pi was very sloppy earlier too here. Yes, my AirPods are on the way out right now. They're at 10%, but I think we'll make it through this video just fine. Now let's say we want the approximate, let's say we do want it to the nearest tenth, or nearest whole number. Let's go 1,131 square centimeters. So the orange would be our exact in terms of pi, and the blue is our approximate to the nearest whole number. So now let's go ahead on example 2 and find the surface area of this figure, but this figure has a cone on the top and a cylinder below. We're actually going to ignore the cone here, pretend that doesn't exist, and just do the surface area of a cylinder. So the formula for that is going to be surface area is equal to 2 pi r squared. And the reason it's 2 pi r squared rather than just pi r squared for the area of a circle is because you don't find just one, but you also find the top up here too. You have both sides. And then you have to find the surface area of the in-between. So the surface area of the in-between is going to be 2 pi r h, where h is the height. So we actually have all the information we need here already. The surface area is 2 pi r squared. Radius is half of this h, because that's the diameter. So it's 4 squared, plus 2 times pi times r, 4 again, times the height of the cylinder, which is 14. So now we just start solving. And if we want an approximate, you can type it all in your calculator. If we want exact, we want to slow down a little bit. So we have 4 squared, which is going to be 2 times pi times 16. Here you can go ahead and take 2 times 4 times 14 if you want, and you'll get 112 pi. If we take 2 times 16, we end up getting 32 pi. Wow, that 5% dropped off quickly. So we have 32 pi plus 112 pi. So our exact answer, or in terms of pi, is 144 pi square meters. If you round this to the nearest tenth, that'd be the surface area is approximately 452.4 square meters. So it just depends on what you're being asked. So that was the surface area of a cone, surface area of a cylinder. Now we're going to do the surface area of a sphere. So a sphere, just think of any ball, although not a football, which is kind of weird that it's called a ball when it's shaped more like an egg. And we have some parts here, okay? So here's a sphere. A hemisphere, or hemisphere, like we know of from a globe, is half of the sphere. We still have a center, just like a circle. We still have a radius, just like a circle. And there's something called the great circle. And that's just going to be the circle going down the middle of that sphere. So it'd be kind of like the equator of our globe to think about. Surface area of a sphere is 4 pi r squared. So it's like our area formula, and we multiply it by 4, boom, we have the surface area of the sphere, the entire outside of it. So let's go and find the surface area of these two spheres. On example 3, once again, surface area is 4 pi r squared. We know the r to be 10, so let's plug it in. Surface area is equal to 4 times pi times 10 squared. In terms of pi, that'd be 400 pi square centimeters. Let's say we want it to the nearest tenth, that'd be approximately 1,256.6 square centimeters. And that is our surface area of a sphere. On to example 4. Here, once again, surface area, 4 pi r squared. We don't know the radius, we know the diameter, meaning the radius is half of that. So we plug 11 in instead of 22. And we have 4 times pi times 11 squared. In terms of pi, that ends up being 484 pi square centimeters. To the nearest tenth, that's approximately 1,520.5 square centimeters. And then the only other example we're going to do is actually example 5. We're going to skip examples 6 and 7. You can cross those out. Example 5. Find the radius of a sphere with a surface area of 1,024 pi square meters. So reminder, our formula, 4 pi r squared, and now we're just solving for the r. So we plug in 1,024 pi as the surface area. And we say, okay, well, what's happening to the radius? It's being multiplied by 4 pi, and it's being squared. We'll undo the multiplication first by dividing by 4 pi. The pi's reduce, and 1,024 divided by 4 ends up being 256. So then we had to square root that to get r by itself. And the square root of 256 is exactly 16. So the radius is exactly 16 meters. That is all for today for section 2.